Yeah, just one last note I want to add to this. I got the equation of that using this technique, which is y minus y, etc., using that, which we've just seen. The other way of doing it, given a point on the line and the slope of that line, we got 7 and 12 and we got minus a third. Okay, we have those two pieces of information. Now I used the point and the slope using this technique, which is fine. The other way of doing it is to say y minus y1, which is 12, divided by x minus x1, which is 7, is equal, and that's like, it's a slope. It's like, you're saying there's any point on this, x and y is this point here, right? Anything on this line. So you go x minus 7, and y minus 12 over x minus 7, y minus 12 over x minus 7. The slope is always going to be minus a third, right? So you can write it down that way. You get 3 by y minus 12, which is 3y minus 36. 3 by 3y is 3y. 3 by minus 12 is minus 36. And then this by minus 1, which is minus 1 by x, which is minus x. Minus 1 by minus 7, which is plus 7. Right? Bring the x over, you get x. 3y is there. Minus 36, bring the 7 over, you get minus 7 is equal to 0. So you get x plus 3y minus 43 is equal to 0. That's another way of doing it, which you may find a little quicker and easier to understand theoretically, because that means it's x and y is any point on this line, and relative to this point, which we know, the slope is always going to be minus a third, right? So that's the other way of getting the equation of a line given a point and a slope. That is the other way there, which it's good to know both of them.